Hello everyone. This video we're going to talk about the printf method. So printf is a convenience method to write a formatted string to the output stream using specified format string and arguments. So we're going to go through the key useful arguments here in this video. But to start off, let's talk about printf. So printf is again used to write a formatted string to the output stream using specified format string and arguments. So the arguments you have to pass in are the format string and the specific arguments. It returns the output stream and it can throw an exception if it contains illegal syntax along with other things. So the first string conversion we're going to go through here is the string conversion. So all conversions have a percentage sign here, as you can see, along with some character. So the string conversion code is a lowercase s or uppercase s, and they both can be used here. So for example, we have a name, John, and then we're going to say hello to John using these printf statements. So as you can see here, this one has a lowercase s and this one has an uppercase s. Lowercase is normal, and the uppercase s is used to force all letters of the string to be uppercase. Also note that lowercase n code is new line. So let's run this. As you can see here, the output, it says hello John in lowercase, and then hello John with all the letters in John being uppercase. Okay, so next, let's talk about Unicode character conversion. So the code for this one is a C or uppercase C. So we have, for testing here, we have a letter, and we also have a Unicode value. So in this case, 65 is the Unicode for uppercase A. So our first example here, we're going to just print out the letter like normal here. So character, the lowercase c, and then passing in the letter as a second argument. Our second example here is we are printing out the Unicode character. So here we're passing in an int. So whatever the value, passing in the int value is going to actually display the value of what we're looking for, which is going to be uppercase A. And lastly, similar to string, we can force that character, so in this case A that we're passing in, to be uppercase with the uppercase C. So let's test this out. So as you can see here, character A, that makes sense. Unicode character, as I said, 65 associates with uppercase A, and then our uppercase character A, because we're using the uppercase C argument. All right, let's move on to Boolean. Boolean is pretty simple. For this, it essentially it just prints out true or false, not 0, 1, but true or false, the words. So as we can see here, we're passing in true and false, and we're passing value 1 and 2 into both of these examples. So the normal Boolean conversion is uppercase B, so just print out true like that, and then same thing with false. And then if it's uppercase B, all the letters are going to print out uppercase. So true and false, all caps. So let's test this out. As you can see here, it makes sense. So lowercase Boolean true, lowercase Boolean false, and then uppercase Boolean true and false here. Okay, so let's move on to decimal integer. You'll probably see this one the most used. At least I've used it the most in practice. There's a lot of different things you can do with this one. So I have a small number and a large number here for testing purposes. But starting off, just using the lowercase d, will print out the basic output without any additional arguments or any additional things done with it. Okay, and our next example printf statement here is we put a 5 in front of the D. So this means that the integer will occupy at least 5 spaces, and it will align to the right. Our third printf statement here puts a negative sign in front of it, which means the same thing as this one, but it will be left aligned, which you'll see what that looks like in a second. Next, our next printf statement here is we have a 0 in front of the 5, which means that the number is at least 5 digits long, padding with leading zeros, which you'll see what that looks like in a second. Putting a positive sign or a plus in front of the D ensures that positive numbers have positive sign. And then lastly here, testing out with a large number, if you put a comma in front of it, it adds thousand separators as you would write them if you're writing on paper. So let's test this out. Let's run it. As you can see here, our first printf statement, 42, it does nothing. Our second one takes 5 spaces aligning to the right, as you can see. Our next print statement makes it 5 spaces but aligned to the left, as you can see. The next one makes at least 5 digits long. It pads with leading zeros. The next one forces a positive sign. And then the last one forces a comma in between to separate out thousands. Okay, let's move on now to real quick the percentage sign. So if you just literally want to print out the percentage sign in a printf statement, it's pretty simple. You just put a second parenthesis. So as you can see here, I am filling 100%, and the percentage sign was not used for anything. It was its own character. So you can think of the code like that. And the first percentage sign is the marker saying that it's a conversion, and then the second character is what the actual code is. So okay, next let's go into floating point numbers. This is pretty similar to decimal integer. Uh, same thing, but there's a couple differences. So starting off, floating point, it defaults to 6 decimal places. But you can control the number of decimal places that using a dot n, where n is the desired precision. So for this one, we have a 2, that's 2 decimal places, and 4 is 4 decimal places. In addition, if you use the pound key in front, you can ensure decimal point even if there's no decimal digits. So that may be important in some scenario. You can also specify minimum widths, just like decimal integer, with a width of 10, with right alignment, and a width of 10 with left alignment. And again, same thing with decimal integer. You can put 0 in front of it to pad with zeros. You can also use a comma to separate thousands. So that's run. As you can see here, by default, it goes to 6 decimal places, but we have the next one has 2 decimal places, and then the following has 4. Obviously, this one had a decimal point before, but there are uses for that. Next, width of 10. We have that right here. And then a left aligned, padding with zeros, and separating with commas. which it acts as a thousands separator, but just passing in this number here, it makes sense. Okay, next let's move on to hex and octal. So unsigned hex is in H. You can same thing with the string and Unicode, the capital version, the capital letter version of the code forces all the letters to be uppercase. Well, in this case, A, B, C, D, E, and F. The signed is X, and putting the pound key in front of here will force it to, make sure it looks like a hex number, and then the octal is just 0, not 0, but O. As you can see, I'm using the decimal thing just to explain. So using 42 here, as you can see here, int number 42, so that converts it to A. So this one is just normal lowercase. Next one with capital H is forces A to be uppercase. And using the pound and the X forces it to have the 0x notation that you'll see. And then in octal, it converts to 52. Okay, next let's move on to scientific notation. There's a lot you can do with this. This is just the introduction for scientific notation, but if you would like, if you want to, please comment with any suggestions, and I would be happy to go more in depth with this. So starting off here, we're just using the same number here, 1 2 3 4 5 dot 6 7 8 9. The basic form of it, E in uppercase E, is normal. It defaults to 6 decimal places, and as you can see the pattern by now, the lowercase e transcribes to using lowercase e, and then capital E uses the capital E. Similarly to decimal and floating point, you can control specifically floating point. You can control the number of decimal places by using .nf, where n is the number of decimal places. So as you can see here, and that should be E, not F. So as you can see here, we're printing out the 2 decimal places because of the 2, and then 5 for 5. If you want, for some reason, the pound flag ensures that there's a decimal point even if there are no decimal digits, which you really won't see it written like this. So I'm not really sure what you would use this for, but it's there. The plus flag forces the sign to be shown for positive numbers, so positive, and then the negative flag left aligns the output. You can also define a minimal width for the output, and the output will be right aligned within 15 character spaces. So that's the example for these two, both uppercase and lowercase. So let's run this. As you can see, the first 2 default to 6 decimal places, like this. Then the first one's lowercase, second one's uppercase. The next one defaults, well, not defaults, but you change this one to 2 decimal places. This one's changed to 5. And then again, you won't really see it written like this, but again, if you need to use it this way, here you go. This one distinctly labels the plus in front of it. This one left aligns the input, as you can see, with 15 spaces, and these 2 right align the input. Obviously, the key difference is the E's lowercase here, and then the second one, E's uppercase. Okay, Finally, let's move on to time and date conversions. And there's a lot here. So it would probably be easier to just run it and we can go through it. So the first two give our hours. Note they're all T, but there's a subcode after the T, lowercase t. So that's where these change. You could probably do a whole separate video on this, but if you guys want that, let me know. So for hour, uh, you can do it in both 24 and 12-hour formats. So right now it's, as you can see, it's 4:16 in the afternoon. So the hour is 4, and then the 24-hour format is 16. 24-hour format is capital H. 12-hour format is capital I. And then now moving on to minutes is capital M. Seconds is capital S. Milliseconds, if you want to go that specifically, is capital L. And then nanoseconds, if you really want to get specific, is a capital N. There's also the AM and PM markers. So right now it's PM, so outputted PM. Time zone offset is as follows. It's capital Z. No, I'm sorry. The lowercase c is offset, and the capital C is abbreviation. So I'm in the Eastern time zone. Next are the Unix timestamps in seconds and milliseconds with lowercase s and capital Q respectively. And then now moving on to the month. So when I'm recording this, it's February. It's February 7th, 2025. So you can use the month full for capital B, so February, and lowercase b for short, so FEB, as you would see in that abbreviation. Similar thing with day of the week, capital A for full, Friday. It's Friday then when I'm recording this, and lowercase a is Friday, FRI. Year, again, two different ways to do it, 4 digits, or in the full way to do it, capital Y, lowercase y is just the 2 digits, so 25. Day of the year, the 38th day of the year, lowercase j. And the month in numeric is 2, and that is lowercase m. Day of the month, lowercase d, it's the 7th. And then these ones output like the full time. So this one, 24 hours with no seconds, is 1616. 24-hour with seconds, as you can see, it just adds that. That's a capital T. The first one's a capital R. And then the lowercase r, 12-hour with seconds, is 4:16, 29 seconds PM. So it adds the PM because it's the 12-hour format. Date with month, day, year, capital D. Date with the other format that you'll see quite often, the year, the month, then the date, with the year being all 4 digits, capital F. And finally, the full date and time. So Friday, February months, date, time, Eastern time zone, and in year. That is lowercase c. So I hope this video was informative. Again, this is just getting started. There's plenty of other conversions. So if you would like a separate video on something specific with examples, let me know. I hope this video was informative, and otherwise, have a great day. Thank you for watching.